because of the declination of the Earth facing to the Sun, so we will see there are about 5 parameter, important parameter that we have to know, we have to study. The first one is the Arctic Circle, with the latitude about plus 66.57 degree. So this line marked the line that marked the southern extremity of the polar day and polar night. The second parameter is Tropic of Cancer. It's about plus 23.45 degree. This line that indicates the highest latitude the sun's line of sight ever reached in the northern hemisphere of the Earth. So this line is the highest latitude of the sun. The sun will reach up to this line or this location. The third parameter is equator. It's about 0 degree. So the line that divides the northern and southern hemisphere equally. Next is Tropic of Capricorn, but it's about minus 23.45 degree latitude. So this line indicates the highest latitude the sun line of sight ever reached in the southern hemisphere. And finally, the Antarctic Circle is about minus 66.56 latitude in degree, line that marks the northern extremity of the polar day and polar night. So, in order to be able to estimate the yield of a photovoltaic plant already in the planning stage, it is necessary to obtain the data of the global radiation at the site. Because if you plan to install a PV system at a certain site, so we have first thing to do is to get to study how much solar radiation we can get from that site. So the most important characteristic of this is the year's total H, or solar radiation, of the global radiation on a horizontal level. So nowadays, global radiation maps are available that show this characteristic in high resolution. So we can download and we can find the solar radiation map for our location. The basis of this is many years of measurement by a dense network of measuring stations, satellites, pictures, and simulation tools. Another option, we can use we can use weather station, or we can get solar radiation data from our local meteorology department. So in case for Malaysia, we can see the annual average daily solar radiation map for Malaysia for different location. We will get different solar irradiation. In average, for Malaysia, the daily solar irradiation is about 4.96 kilowatt hour per square meter. To do site analysis, we have to consider two things that will affect our performance of PV system that we will install. Maximum performance is achieved when modules are perpendicular to the sun's rays, which is we can face directly to the sun. The first thing is about PV module direction and orientation, whether to face to the north or south, or to face to the east or to the west. The next one is about the tilt angle, how to tilt the PV modules where we can directly face to the sun. Photovoltaic plants are mostly installed on pitch roof, so that the module is at an angle of beta to the horizontal, as shown in the figure below. We can see that the PV module we tilt to certain degree in beta in order to make sure the PV module directly face to the sun. Also, in the case of flat roof or open air plants, it is usual to tilt the module in order to achieve a higher annual yield. So we can use many measuring tools, equipment, in case if we don't have data about solar radiation and so on, we can use equipment ourselves. If we have enough equipment to measure solar radiation, so we can collect the data to design our own PV system. One of the measuring tools we can use, such as sunshine recorder, which is a device that records the amount of sunshine available at a given location, a certain location. Another equipment that we can use is parallelometer for measuring direct solar radiation. The instrument must continuously track the sun. Another important measuring tools or equipment, we can use the Solar Pathfinder. Solar Pathfinder provides very fast, accurate. We use this for solar site analysis. In just a minute, the Solar Pathfinder can determine, can find and record year-round and site-specific solar data with precision and ease. The use of Solar Pathfinder is very useful for studying the shading effect at a particular site. So we can use this equipment, these tools, we can study, is there any shading effect around the certain location if we plan to put PV system at that site. Another important useful tools or equipment that we can use in measuring solar radiation or energy from the sun, we can use pyranometer. Pyranometer we can use to measure the solar irradiance that coming from the sun. The same for solarimeter. We can also measure the solar irradiance or solar radiation from the sun. However, pyranometer much more accurate compared to solarimeter. Another equipment or tools we can use is weather station. By using weather station, we can use to collect the same data such as solar radiation. It's not just that. We can also measure the temperature. We can measure the rain, the wind speed, and many other. We can collect any other data. Because weather station, we cannot just read the data, but it can also log. We can acquire more data for a long period of time. Another useful equipment or tools we can use when we want to design, we can use to when we want to install a PV system is the first is thermometer, or we can use infrared thermometer. So this thermometer, we can measure the performance of a PV module or PV cell, which is we can measure the temperature of the operating temperature of the PV cell. And the second one is sun eye. The function of sun eye is similar to Solar Pathfinder, so we can track the sun movement. We can track the sun. And then the effect of shading, but it's much more advanced equipment compared to Solar Pathfinder, but it's very easy to use. And then the next one is magnetic compass, so we can use to find the direction, north, south, east, or west, and we can find the best orientation to face the PV module. And then the next tools is the inclinometer. So inclinometer, we can measure the tilt angle of the PV module. We can find the best tilt angle that can directly face to the sun. So there are many other equipment or tools that can be used, or it's very useful when designing a PV system. Maybe there are many types of equipment or tools available now in the market. We can find, of course, it will help us to design better PV system. So that's all for this module. Thank you for watching.